I moved to the Birmingham area in 2000 and have really enjoyed living here and being a part of this community for that time. But today I want to talk to you about the smart neighborhood. And what I'm going to discuss really is sort of where it began, the concept of this, and some details around, what it is and what we're doing there. And then also some things that have launched even beyond that. So, the way this started was several years ago. The electric utility industry, the business model for the electric utility industry is over 100 years old. Very few business models survive that long, but it is over 100 years old. And if you think about how the business works, is there's a huge amount of capital investment in power plants and transmission lines and things. And those investments are recovered over decades of horizon planning. And so that's sort of how it's always been. But in the last several years, there's been ongoing change in the industry and talks about change around with that are really available through technology. Uh, the internet is a big technology that is changing our business. Distributive energy is a big technology that the cost of is coming down. It's changing our industry and a variety of other things that are involved. And so it began a lot of conversation internally to our group, to our company, about what is the future going to be in terms of the electric utility industry. And so you would enter into these conversations with people who would develop opinions about which trends were going to bear themselves out. And what I began to realize, and I was in these conversations, is that they were simply opinions, very learned opinions, very knowledgeable opinions, but opinions nonetheless. So we kind of thought about, is there a way that we can understand the future today by maybe creating the future now and then learning from that from a variety of ways. And so that's what we thought. We thought the smart neighborhood would be that concept. Could we build a neighborhood that represents 20 years in the future for the state of Alabama and look at that and understand the ramifications of that today to help us plan for our customers and meet our customer needs and our business model going forward. So we sort of began that conversation that led us to the smart neighborhood. And so we sat down and we said, hey, what we want to do is really build a living laboratory to help us prepare for our customer needs and expectations. And at its heart, it's a research project around three basic areas. The first of that is a distributed energy. There's a microgrid that connects to the neighborhood, and I'll speak to that. And we wanted to understand how microgrids work, how they interact with homes, how they interact with our grid, a larger grid, all those things we don't have any experience with. So we wanted a microgrid to understand them. We also wanted to understand how efficiency or energy efficiency is going to change over time. And so we wanted to build these homes to be hyper efficient, but would really represent an average efficiency of 2040 timeframe here in the state of Alabama. I'll talk more to that too. We wanted to understand the trend of internet devices, the Internet of Things, how the connected devices in homes, where it might change the way the experiences are in the customer's eyes as well as the utility. And then the last area we wanted to look at something called building to grid integration, which I think is very exciting and is potentially going to change the way that the customers interact with the utility and the utility interacts with customers. So in essence, we sat down to try to say, hey, what we want to do is to come up with this neighborhood to represent the future today so that we can get real learnings across these three areas with the customers. And so we call it a living laboratory because the homeowners who purchase these homes, they're engaged in this research project as well, because customer behaviors and attitudes are very important to us to understand how they interacted with these homes as well. So we sat down and we planned this out, and we really thought about what this would look like. We thought, okay, we need about 50 houses to make this work, and we'll need a microgrid and some things. And so we sort of did a drawing, if you can look at this, and this is kind of how it looks. We ultimately found a location at Ross Bridge It's called Reynolds Landing, and you can see the houses there. And then over to the right, about a mile away, is the microgrid. Now, the first thing we had to do is find a builder that wanted to partner with us to do this project. We don't build houses, we don't buy and sell houses. And so we needed to have somebody who knew, had that expertise, that was willing for us to partner with them and make this project happen. And so at the time, about the 2017 timeframe, in the state of Alabama, there wasn't a lot of home construction. And so we really searched around for where we could find a project. And as I said, we wanted to do about 50 houses. And we approached Signature Homes here in the Birmingham area, and they became interested in it. They had this project that they were just about to start at Reynolds Landing. You can see it's 62 homes. So we tried to make that work. And then we wanted to locate the microgrid within reasonable distance. In fact, I initially had a concept to have the microgrid inside the community itself. Well, it wouldn't fit in that community. The footprint wouldn't fit. So we tried to find land as close to that as possible and started finding some parcels. This is in the Shannon Valley area, and ran into some issues, environmental issues on property and whatnot. But we finally found some property that worked, located. And if you notice, there's a right between the neighborhood and the microgrid, there's a multifamily apartment complex. One of the covenants that we had to achieve was inside the microgrid. It's made up of solar, battery storage, and there's also a large natural gas generator there. We had to have sound requirements that at those apartments, the sound of that generator could be no louder than a residential air conditioner. So that required us to come up with some soundproofing and things to meet those requirements. But in essence, that is basically what we ended up with in terms of the structure. We partnered with Signature Homes, and so we're off and running. Now we had a potential project, but we kind of sought out other partners, and people really came to the forefront that wanted to partner with us. The first one was the Department of Energy's National Laboratory, Oak Ridge, Tennessee. They're a research facility, and they mainly are researching microgrid controlling devices. And so they approached us, and they have a couple of controllers that they wanted to test in this project. And so they came forward, and we said that would be great. And then there were a number of vendors that wanted to come forward as well. Carrier, who has a super efficient heat pump, low temp heat pump. I'll talk more about that. They wanted to test that device. Ream, who has facilities here in Alabama, they had a brand new heat pump water heater, which is the very most efficient way you can heat water. They wanted to test that. EPRI, which is the Electric Power Research Institute, they wanted to help with the data that we were collecting from these houses. To give you some scale and perspective, Alabama Power has about 1.4 million residential, commercial, and industrial customers in the lower 2/3 of the state of Alabama. Each of those customers has an AMI meter, meaning we're reading their meters digitally over the internet. We are collecting more terabytes of data from these 62 homes and all the other 1.3 million customers combined. So this is a massive amount of data we're collecting from these houses. And we used EPRI has been helping us figure out how to move and compile that data and analyze it in a way that's been meaningful. Vivint approached us about being a smart home partner for this project, and Samsung wanted to put some appliances in the homes as well. So all these people came together. It was very interesting. We began to talk to these companies. The marketing and sales groups of these companies were very excited to be in this project. But when you talk to the legal departments, it became a different conversation, because what we're doing is we're pulling the data from each of these appliances into a single place that's stored in the cloud. And then we're analyzing that data and disseminating it back to the partners. These are very proprietary platforms with Carrier and Ream and Vivint. They didn't necessarily are used to sharing their data. So we had a lot of negotiations, because this became a first of its kind project in the country. And what I mean by that is there are certainly projects out there where people have built energy efficient homes. There are places where people have built microgrids, and also have done the Internet of Things type projects. Never before has anybody done all these things combined And so this garnered a lot of attention in the industry, the home builder industry, the utility industry, and subsequently it's won numerous awards for this project. So we've been very pleased with how it all worked out. But in essence, we're really looking around research components around four basic areas. The first I mentioned was customer feedback. The homeowners, when they built, or excuse me, when they bought their homes and they moved in, they signed an agreement for the initial 24 months of their home, of their stay there. All of the data that I mentioned was collected, was available back for us to examine. Plus, they were asked to participate in focus groups and feedback sessions to tell us things they liked, they didn't like, to give us opportunity. Customer behavior is the hardest thing for anybody to really understand. You know, engineering and technology, it works or it doesn't work, but customer behavior can change so dramatically based on people. And I'll talk more about that. The other was the energy efficiency component of these homes. We wanted to understand how these homes would use energy, what that load shape would look like, how that would influence our needs for generation and distribution and things. This transactive control approach is really this building to grid interaction in which the grid interacts with the devices in the home in a way that's unknown to any of the participants to manage both cost of energy and comfort of the consumer. And I'll talk more about that as well. And then finally, the community scale microgrid. We wanted to understand the economics, the operations. How would we use these resources? Would they be used to offset some peak? Would they be used to isolate the neighborhood? All these different things we needed to learn more about. So these are the basic research components that we looked at. I'm going to walk through each of these in a little more detail, but that's the basis of the Smart Neighborhood Project. So first with the customers. As I mentioned, the homeowners signed this agreement to be a part of this research project. And so what we learned really right off the bat is that consumers want technology to make their life to simplify their life, to not make it more difficult. And so when you think about an old guy like me, if you go back when home computing started to be prominent in the 80s, you go buy a home computer, you still had to know a lot about computing or how things worked in that box to make it work and to get any kind of productivity out of it. Today, you go and buy a laptop computer, you come home, it's all ready to go. You don't need to know anything. You point and click, and it's a real tool to get you what you want. You're sending email or you're doing something on Facebook or some social media platform. You don't think about it as a computer, it becomes a tool. And that was the vision of those people who thought about home computing. And that's what consumers want with internet devices. They don't want a whole an array of devices that don't work with each other, that they have to be experts in to know how to use. They just want them to work. So what we learned was when homeowners would move in, we set up a procedure to go in and set their homes up for them. So the connectivity part of the home was around security, entertainment, and energy efficiency. And so we would go in, these homes were built on the Amazon Alexa platform. And so if you have one of those devices, a lot of people just use them to do fun things with or set timers or some things like that. These homes were really built what they call scenes around these homes. For example, you could go and individualize one to say, Alexa, good night. And what that would do was it would turn lights off in a sequence. It would set the thermostat on your air conditioner or your heat pump to a certain degrees, and it would lock all your doors. Turn on the outside lights. Boom. You wake up in the morning, Alexa, good morning. The coffee pot comes on, the blinds go up, certain lights in the kitchen come on, whatever you desire that to be. We could build those scenes for you to really integrate that home experience versus just having a one-off approach. So customers really wanted that simplicity. They wanted it to be stable and work. One of the things they really wanted that it's difficult to do is have everything work on one app. And so if you think about Google Home is just now beginning to put that together, but everybody wants to have one app And the other thing we learned is when something's not working, who do I call to make it work, right? And so it's interesting how customers have experienced this and been a part of this, and it's been we have seen them become seamless with these homes in the way that they interact with them. Next were the homes themselves, and I mentioned the energy efficiency part of these homes. And the efficiency was created two ways. One was the construction of the homes created efficiency, and then the other was the appliances, mainly the heat pump and the water heater, the big users of energy in the home, meant that. So to give you some kind of perspective, homes are valued in terms of energy on something called the Home Energy Rating System, HERS, and it's an index. The average home in Alabama, will new home construction will be in the mid 70s on that index. These houses were built at a HERS rating of 45, so a significant change from the average home today. And it was done again by construction and around the appliances. You can see very heavy insulation on these homes, triple pane windows. The homes were built so tight with sealing, all the seams were sealed so tight that they had to place air exchange devices in the homes like a commercial building to bring outside air in to keep enough fresh air coming into the houses. One of the stories we heard in construction, the builder told us as they were building these homes in the summer, they were doing the sheetrock, and the sheetrockers, really hate doing that work because it's hot in those homes. And you go upstairs and it's just burning hot. These homes, there was no temperatures before any HVAC equipment was installed. There was no temperature difference between the first floor and the second floor just on the construction of these homes. So it was very, very tight. Now, one of the interesting things too is while we were trying to create homes of the future, the builder, Signature Homes, was selling homes today. So they had some requirements. They said we couldn't impact the homes cosmetically. We couldn't make them look any different. And there were certain products that they were uncomfortable with that would help the insulation of the homes. And so we had to work around that and figure that out. But the other part of it was the HVAC and the water heating system. The Carrier air conditioner, it's a 20 SEER HVAC system, and that's just a rating. To give you perspective, the standard rating for that in Alabama today is 13 SEER. And it's a low temp heat pump, meaning it takes heat out of the air and puts it in your home. And it does it such that it can be extremely cold and still be able to extract that heat. It's one device for the home, but it controls different zones in the home. Providing either the heat or the cold air to that particular area of the house. Very smart. Everything's variable on it, and works very well. For example, on a cold day in January, it was a 24-hour period where the temperature never got above 32 degrees Fahrenheit. And so typically in that environment, a heat pump can't get enough heat out of the air to deliver it to your home. And it has to turn on strip heat or resistance heat inside the device, inside your home, to bring that temperature on up anymore. These devices never had to turn on that strip heat, which are big energy users, and just ran off the compressor throughout that whole 24-hour period. It really changes the load shape of a home. The heat pump water heater is just a heat pump water heater in which the heat pump sits on top of a tank and it takes heat out of the air and puts it into the water. Extremely efficient. A standard tank water heater has a coefficient of performance or an efficiency rating of about 0.9. It gets about 90% efficient. Heat pump water heaters have a coefficient of performance of 3. They're 300 times more efficient. So extremely efficient way to do it. So throughout this, we wanted to know how efficient can we make these homes. Not practical today necessarily, but this would be standard construction 20 years from now. So very interesting for us. The other part of the home was the connectivity of the home. And so we put in a lot of devices to connect it, and you can see them there. Very interesting. these are all Samsung appliances, and the salespeople for Signature Homes, they told us these homes sold pretty fast for them, and they said that the biggest selling points was the microgrid concept and this refrigerator. You see a picture of it there. It's a Samsung refrigerator, and it's basically an internet hub, and it has a lot of smart features on it. One of the it's interesting things is you can be at the grocery store, and on your phone you can look inside. You can reconfigure the different areas on the refrigerator to be freezer or not freezer. It just induction cooking. I don't know if you know what induction cooking is, but it's a super fast way to cook with electricity. You turn it on and you put your hand right on the eye of the stove, and you don't feel any heat because it's not heating up an eye. It's inducing a coil current that just goes into the metal pot. So it'll boil water just like this, and then you can remove the pot, stick your hand back on the eye, and there's no temperature there. Very, very sensitive up and down temperature. You can control temperature very well. And so all these devices were connected and engaged in the home through the Alexa voice assistant application. The other part was this transactive control that I mentioned earlier. And this is that building the grid concept. And so there are two ways that there are two devices that control this. One is it's called seismic, and it controls the microgrid itself. And so there are three components of the microgrid: the battery, solar, and the generator. And it manages those loads or manages those generation devices to make whichever is the most efficient to do. And then Voltron takes the energy that's in the microgrid, and then it tries to translate that to the homes. And so what it does is it optimizes the energy in these homes by managing the water heating and the heat pump in a way that manages both energy cost and customers' comfort. So when customers moved into these houses, they said, here's my comfort range. I want to be between this temperature and this temperature. And so Voltron then looks at that and individualizes that and then manages these devices to reach that while minimizing energy costs. So that what that means is it may turn on the air conditioner or the heater early in the morning or middle of the afternoon, even when no one's there, to preheat that home or pre-cool or preheat your home to get it in that temperature, but use energy from the sun to do that when it doesn't cost you anything. Same thing with water heating. It's really interesting. You can go to these homes on a 60-degree spring day, 65 degrees. It's very sunny outside, and walk into the garage and the heat pump water heater just be working away. And no one's using any hot water. And you want to know why? It's because Voltron is taking free energy from the sun, dumping it into the tank of your water heater, getting it hot for you to use later. So that's the concept of you decide what you want your temperature range to be, what you want your cost to be, and these devices control those things in your home in a way that's not intrusive to the consumer and manages that to optimize both the grid and the homes. It's the next generation of sort of demand side management as well as cost containment for the homes. It's interesting for us, and I'll talk more about that. It's kind of how we've expanded this pilot as a way to create energy efficiency for customers going forward. The other part is the microgrid itself, and so obviously very interesting. It's like I said, it's about a megawatt of generation. It's made up of the solar panels, and there's battery storage, and then there's also the um, the natural gas generator. And so each of these devices can be connected to the homes individually, or they can be jointly connected. We can isolate the homes and just run them off the energy from this, call that islanding, or we can integrate this into the grid and pump this energy back onto the grid and let the homes take their energy off the grid. But it's been an ongoing experiment with us to figure out how to best utilize and configure the use of this device, this microgrid, within the overall confines of the home. And so it's been a learning experience for us to understand how to do that. You'll notice where it says load bank, there's this giant device out there that we can test all of these devices, put a load out there to pull the current through and do the testing without disrupting the homeowners if we're trying to test a new device or a controller or there's an issue with things out there. But this is all remotely done. Um, we control this from our central location, downtown Birmingham, and we send signals back and forth to the devices to operate them or not operate them. But it is connected to the homes directly, and then the homes are connected to the grid. So the energy can flow multiple ways from there. So that's basically the various components of the smart neighborhood and how they all interact and work. Um, it's adopted us for some key learnings around energy savings and distribution impacts, microgrid capabilities, customer behaviors and expectations, and data infrastructure. One of the things that we've learned is you never really can predict what's going to happen until you get these kind of devices out there. One example was inside each home there was a device that enhanced internet connectivity. Obviously, these houses have to have a lot of internet connectivity, and there was a device made by Google that enhanced the Wi-Fi ability in your home. And what we experienced was that a number of homes were seeing very slow speeds in their Wi-Fi. And we couldn't figure that out. We didn't know why. And so what we discovered was these devices that I mentioned, these Google devices, they operated on a specific channel. And these homes were very close together. And what was happening is these devices were connecting to themselves from one home to the next and bogging down the internet. So we had to go back and we had to break it up. We had to put Google and AT&T devices in between so that they wouldn't connect. Things we wouldn't have known had we not done this. Same thing with the microgrid. Or the controller that we have, the operator would press a button and that button would island the neighborhood. It would just isolate the neighborhood and only run all the homes off the energy from the microgrid. And so one day we were doing a test, and so he pressed the button, and he wasn't sure that it island. So he pressed the button again, and it created a firestorm of failures at that point. What we didn't know is that the manufacturer of that control panel had built into the system that if you pressed it twice, it interpreted that as some kind of fault and locked everything out. We wouldn't have known that had we not done those tests. So we had to work with that manufacturer to change that protocol, give some feedback to the operators that when they pressed the button, they got a feedback that the islanding had occurred or it not occurred. The data infrastructure, as I said, we had to create a whole way of moving massive amounts of data that we are still collecting from these homes in a way that we'd never known before. And so it's huge amounts of data, learning how to do that, and the customer behaviors and expectations. I can't emphasize enough how those vary from home to home. These homes, while the floor plans are slightly different from each one, they basically have the same energy profile. And when we measure the energy usage, it varies greatly from one home to the next. Now, some of it is because of family size, but a lot of it is just behaviors. While you may find 72 degrees Fahrenheit very comfortable, your neighbor may find that very hot or very cold. And so they will have varying degrees of what is comfortable. Is so individualistic that it is hard to predict large amounts of behaviors across a broad spectrum of people. And that is learning that we have had. Seems intuitive, but we thought it would be less so because the homes were so identical to each other. But vast amounts of learning to this, and it's translated into ongoing program development here at Alabama Power. And so a couple of these I will talk about now. The first is we call the Smart Neighborhood Builder Program. So this project was very unique and very research focused, but other builders approached and said, I'd like to be a part of this. And so we came up with a program offering that tempered down some of the energy efficiency requirements, made it more of I said, a HERS rating of 45 for this project. We put them in about the 65 range and showed them how they could get there, did the Internet of Things for houses, and gave them that approach. Customers are now, we've got 4 or 5 of those projects underway across the state of Alabama, and have people have really enjoyed it. The other is a program we call the Smart Advantage Optimization Program. I talked about that building a grid integration. We have partnered with a company called Uplight, who was able to do this on a larger scale, and we're doing a pilot now across the state with some customers outside the smart neighborhood to give them a pricing signal to your time of use pricing and let them optimize what their comfort level wants to be. And then we will send them, we will be able to manage their energy usage back to their comfort level and try to minimize their price or their cost of energy. So we're testing that and learning that as well to expand that program across a broader scale. And then finally, Alabama Smart Options program is a way, we mentioned Vivint was our smart home partner throughout the Smart Neighborhood Project. And so we're now able to connect other customers to Vivint and allow them to come in and customize smart home security and entertainment devices for those homes as well. And they contract directly with Vivint there. So that is sort of the smart neighborhood as we know it. I'd love to take your questions, or if you have any, or your comments about this project and what we've done.
Well, first of all, Mr. Rath, thank you. This was very informative. I'm quite interested in this. I have to admit, I didn't know exactly what the topic of smart neighborhoods was going to cover. And actually being an Amazon Echo user myself, and I haven't automated our dishwasher or the locks on our doors, but I do have the lights in some of our house and music that I use this. So I have some little vague info. But I have a question about your microgrid. Is
Okay.
the microgrid supply, or can it supply 100% of the power needs for these 62 homes? And is it the idea that Alabama Power would maybe in the future expand this idea of microgrids to include providing power to other places?
So to answer your first question, yes, it can provide 100% of the energy to the homes. It can island the homes. Remember, it has 3 sources of generation. One is the sun, the other is battery storage, and the other is the generator. The generator can run those homes forever, right? Because there's natural gas. Take that out of the mix and just look at the renewable component of the solar and the battery. We've islanded those homes for up to a couple of weeks for testing. So theoretically, you could have a disruption of some kind. Depends on the sun. It depends on the time of the year. The colder and hotter it is, it's harder to maintain. But like a day like today, certainly you could go forever just with the solar generation that you get from the solar panels. But excess solar is stored in the batteries. The batteries themselves can run the home for a couple of hours. Okay. But the solar panels, as long as you have sun, so if you have sun during the day, it's going to get dark. The batteries can go for a couple of hours, depending on how the usage is. It could go all night if you're not having to run your HVAC systems and things of that nature. But the natural gas generator would come on and run forever if it had to. So, and as far as your second part of your question, that's what we're doing. We're studying the impact of distributed energy and how it integrates with our grid. And so now we have a stake in the ground. Could we build more of these? Should we build larger microgrids? Should we build smaller microgrids? What's the optimal way? Should we use them to bolster a feeder that's struggling at the end of a line somewhere? Would it be used as peak power? There's a lot of use cases that we're going through right now to determine what's the best thing to do going forward with distributed energy.
What about
I have a question regarding the HVAC system. Number one, is there a particular thermostat that you used? And number two, does your HVAC system include smart vents?
It does not include smart vents. As far as the thermostat, it was a proprietary thermostat from Carrier that only worked with this device, this particular heat pump, which created an issue for us. We would rather have used a Nest or an Ecobee internet ready thermostat, it would make it more easily to integrate. But Carrier at that time, it didn't work with those. So we use one of their proprietary thermostats.
The reason I ask is we have a fair amount of experience with the ecobee thermostat, and it, as you're aware, has different sensors you can put in different rooms to really regulate the temperature in your home very nicely.
I have an ecobee thermostat in my home.
Yeah, okay.
Yeah, but it wouldn't work with this particular device. We that bad. So one of the problems that we're experiencing here's an issue with the thermostat manufacturers. The big two are Nest and ecobee, and then there's a myriad of others. Emerson makes one and whatnot. But they are all creating a proprietary world, sort of like Apple phones and Android phones. And they don't want to mix and match and have open protocols. And so that creates us in a position that we pick one over the other, and then the consumer doesn't have the choice to work with our programs. And it's a big mess right now. We're trying to tell them, don't put us in that position. Let your thermostat work with whatever program we come up with. It's better for everybody. Y'all win in the area of marketing and a better mousetrap, so to speak, and not through some proprietary, picking winners and losers.
I got a question about solar. You've got solar built into the microgrid, right?
Yes, sir.
But Alabama Power has been they've taken a position where they actually penalize a lot of people for adding solar to their house. And other states around the Southeast, I know Georgia, rewards people for doing that. So why is Alabama Power's position the way it is?
Well, I would have to answer that. That's a regulatory thing. I'm not really involved with all those regulatory environments. So I don't really have a position to talk about.
Okay.
I'm a marketing guy.
I have a question in relation to when you're speaking to the future homeowner and he says, well, I want the whole package. Can you say that will cost you X amount?
I'm not sure.
Or you want a 70% package of sophisticated equipment. And what would be the overall savings, if any, from current use?
Well,
in dollar amounts.
Yeah, on these houses, so it's always dependent. The average bills in these houses were, I think, average energy bill was around $130, $135, $40. And listen, it's so dependent upon how you use energy. I can state it would be 35 to 40% less than what your normal usage would be with everything being equal. But with everything's weather driven, and how you use energy is so it drives what your costs are. So if you moved in one of these houses and you never wanted to, you could get it down to $50 a month probably, but you also could spend $300 or $400 a month, just depending on how you use it. But on average, it's 35 to 40% less cost. These houses, but the investment made in these homes was, several $1,000s above what normally would be done. Like I said, these were not economical decisions necessarily today. There was a delta between what you would do today and tomorrow, but we wanted to understand what 2040 looked like, not 2017.
And additionally, would the maintenance costs on all the sophisticated sensors be justified, or could you expect a trouble-free service for maybe 5 years?
Well, all the devices have a standard warranty with them, and so you shouldn't see any change in any of that. Most of the sensors that I'm talking about were sensors that we put in. We're measuring things down at the circuit level. Those were sensors that we put in to collect the data. You wouldn't necessarily have that in a home that you built yourself. You wouldn't need all that. And so those sensors are things that we maintain to keep that up. But the rest of the devices, the HVAC system and the appliances, they have a standard warranty, just like everything else. And so I wouldn't expect a life of life to be any different on that than any other appliance that you buy.
I understand how the microgrid in this case was to test the feasibility. If it was to be expanded, would microgrids be considerably larger than just 50 or 62 homes? And how does the cost of generating the power from a microgrid compare to what it is that Alabama Power on average can generate power from its combination of?
Yeah, and so that's an ongoing conversation. The costs around microgrids in terms of solar and battery storage is continuing to go down at a very fast pace. And so, in fact, you'll see a lot of utilities are really expanding utility scale solar projects now as a source of generation. So as those costs continue to come down, it's always going to be a lot more competitive. How things have worked in the past is we have central plants that have huge economies of scale where they were coal, natural gas, and now it's just transitioning to solar storage and in battery storage, or solar generation and battery storage are coming next to be. While they're probably not the most economical today at this size, that's what we're wanting to test. Should we build larger ones? Could you do smaller ones for very specific purposes? Those are things that we're going to learn over time to see what the next phase of our generation mix looks like.
Do we have more questions?
Are these microgrids absolutely independent of the Alabama Power normal grid that what the rest of us are on?
They could, this microgrid could be, it can island just the homes and isolate itself, but it's also connected to the grid. So the controllers can take all that sun energy and put it out on the grid if the homes aren't going to use it, or it can pick up a feeder or something of that nature. But then again, they can isolate the neighborhood with just a microgrid so that it's independent. So we wanted a variety of different test research scenarios. So we left all those options open.
How much? It seems that there are a lot of homes that will be very, very expensive to convert to this solar system. How are they going to project to the future that many homes can be converted without extremely expensive cost, which would not be efficient for many, many years?
I'm not sure I heard that. Phil, did you get that?
I think the question was that in the future, to convert existing homes, the cost of the appliances and various things that are required for something like one of these smart homes would be beyond what many people could afford to.
Well, so that's a good point. That's why we're saying is we see this as standard. If you think about 20 years ago, the efficiency of appliances and devices and home construction was much less efficient today. These homes are going to be what we think will be standard in 2040 timeframe. So we're not expecting everybody to do this overnight. Over time, this is what the trend would be. If you think about lighting, for example, we now all have LED lighting, or a lot of people have LED lighting. That has permeated the homes and businesses over time. And so we would see this as well. We don't see people running out and converting their homes to these standards. We're just trying to understand what we're going to have to do to serve the infrastructure that we would need to serve these homes could be a lot less than we would need in phase past. The way our grid is designed, this is the way a non-engineer explains it. We have to build a church for Easter Sunday, right? So there's a hot days in August. You think about Alabama in August and September, how hot it is. We have to have enough energy to meet those days. It's cold in January. We have to have energy to meet those days. And so we have to have all this equipment in there, and we may not utilize it. And so that creates some inefficiencies. If you can have a lower band of what those extremes are, then you don't have to have as much investment to serve those homes, and it lowers everybody's costs. So that's what we're thinking about these homes. Other questions?
Do you mean that you are mainly assuming that
What was the average
the
sales
system could be
price?
put into new homes that are newly constructed, so they will have the proper roof and the proper insulation and things that would be difficult to put into an existing home without a new roof?
It would not be cost effective to retrofit a home, existing home, to these standards. Certainly, you can do things that are cost effective in your existing home, making sure that you have, good insulation, you have you have good window seals and things of that nature. Have an efficient HVAC system that has been maintained and is in prime operating condition. Those things are critical. A programmable thermostat is one of the easiest things you can do to help lower your energy costs. To get that thing programmed into a certain comfort level that you can work with, and keep your energy there. You're making sure that you use energy at certain times and things of that nature as well. So,
yeah, replacing all of the windows in our house with triple pane windows would be a rather expensive proposition.
Yeah, and it wouldn't be a payback for you to do that. I mean, energy cost is not that high. Again, these were extreme to create a future versus a past, or versus a current today.
What was the average sales price of these houses, and how did that compare with the sales price of comparable houses of comparable size built to current specifications?
Yeah, so the average sales price in these homes was around $385,000. And so again, we had those manufacturers donated all of that equipment for the most part. So it kept the price within. I mean, that was one of the things the builder said. I can't ask people to pay a premium for these homes, and they buy them. So we had all this equipment was donated basically, and we put in the sensors. And the trade-off was these consumers had to sign up and be a part of this research project. We were very intrusive with them about capturing all their data and tweaking their thermostats and things of that nature. And so they had to put up with those inconveniences, and that was the trade-off for them to buy these houses.
Have you had any interest from builders about doing subsequent projects of this sort?
Yes, that smart neighborhood builder program that I mentioned, we've had builders approach us that wanted, again, not to the extremes that these houses were, but a step up for efficiency, internet provided, no microgrid, obviously. We had one builder in Mobile that's talking to us about maybe building a neighborhood and putting a neighborhood-sized generator in the neighborhood for storm protection, right? You would pay a premium as a member of that neighborhood, but it would all be a closed underground circuit to your home. And when hurricanes come through or whatever, and you're going to be without power, every home would be provided with backup generation. Haven't done that yet. We're just in conversations with them. And so there has been a good bit of interest in this. But, it's most people build and buy homes because of cosmetic things, not because of the energy components of their home, right? When you go with a real estate agent to look at a new home, they show you the flooring and the cabinetry and the stuff in the bathroom. They don't show you the HVAC system or the water heater system. It's just not something people think about. And in Alabama, our energy costs are not that high, so they don't drive that. But over time, this is going to be standard construction and nothing really outside the norm.
Thanks.
Okay. Any further questions?
Yeah.
Well, Todd, this was a very interesting talk you gave today. I'm really glad that you came and spoke to our group. And as I said, for all of those, for anybody that would like to see this, I will post this to our YouTube channel for New Horizons BHAM probably in the next day or so. So if you missed any of it. But I guess we'll see you all either tomorrow for Friday Forum or next week's talk on Wednesday, which I don't have in front of me, but I will let you know by email very shortly. So thank you for joining us. Thank you again, Mr. Rath.
Thanks. Enjoyed it.
Thank you.
All right. Goodbye.
Bye.
Bye.